All right, so I think we have our main speaker. We can kick off. So, welcome, guys, to the 15th session of the Papers We Love Nairobi Meetup. And today, I'm personally very excited for a few reasons. The first reason is this is my first time hosting the PWL concert. So, I'm very excited, I'm very nervous, but I'm looking forward to it. Today also we have something to do with training language models to follow human instructions. I will not even attempt to go into the depth of that because we already have a resident expert, our speaker for today. So I'll take a few minutes introducing him, letting you know who he is and why we should all be paying attention. Then I'll give him the floor to take us into this paper. So our speaker for today is Gilles Hacheme. I may have severely butchered that name, but thankfully he has the chance to give us the proper pronunciation. And he is a senior research scientist at Microsoft AI for Good. So already this is an expert in his field. And today we're going to be talking about training language models to follow instructions with human feedback. A little preamble is that, well, for these AI models, we've seen them coming out one after the other, and they keep on getting bigger and bigger and bigger, 175 billion instruction sets. But if you're like me, you've ever used AI before and it gave you something that was completely wrong, or something that just didn't match, or something that was, in some extreme cases, really harmful. So bigger isn't always better. So Mr. Gill is going to take us through this paper and how they worked with his team and the different research they put into this work to getting these AI models to get better and better with smaller models based on human instructions. So without any further ado, Gilles, welcome, and the floor is yours.
Yeah, thank you so much, Brian. So actually, my name is Gilles Quentin Hacheme, and I definitely understand it's not the easiest to pronounce for a Kenyan, though. So it's completely fine. So today we're going to talk about language models, and especially how do we make them follow instructions. So I'm presenting most of the content I will be presenting today is derived from the OpenAI paper, Instruct GPT, that you can all find online. Yeah, and maybe more about me. So I'm a senior research scientist at Microsoft AI for Good Lab, where we generally use AI for social good. It can touch on many things, from like defending human rights to helping humanitarian organizations achieve their goals. In cases such as disaster response, food security, and other things. And we are also increasingly interested in using language models, especially tailoring them for the global south, especially Africa, for different use cases. So again, some of the things I will be presenting today, some of them are coming from the paper, and others are like things that I've added to make let's say what I'm going to present understandable for all of you guys. I will try to not be too technical, but there will be a few things. And please, if you don't understand something, feel free to like raise your hand or send a message on the chat. I may not be following the chat, but maybe Brian, you can let me know if there is any a standing message that I should answer. Cool. So let's dive into the subject. So it has been 2 years, right? Of ChatGPT, of the ChatGPT era. And it looks like ChatGPT came 10 years ago. I don't know for you guys, but this is so surprising to me. Like the feeling of like, is is that revolution just 2 years old? And the interesting fact is that when ChatGPT came, I mean, even people who were working on language models before ChatGPT have been surprised. And just imagine how, let's say, shocking was it for the whole world to realize that AI could now uh, multitask from translation to writing to coding and so on. So let me be transparent here. I think most of the people, I mean, I guess most of us who use smartphones, computers, and so on, before ChatGPT, we have already we have already interacted with AI systems, right? Whether you use translation systems or search engines, or like even when you go on a shopping website, in behind the scene you have a recommendation system, right? You guys use Spotify, and I guess you all know how Spotify and all other apps do recommendations, right? They just learn from our preferences. But what is very kind of not just shocking, but very I would say interesting with ChatGPT is its ability to perform different tasks at the same time. So you can ask it to translate. You can ask it to write a letter. You can ask it to write an email. You can ask it to debug a code. You can ask it to even reason about mathematical problems and so on, right? And so that's exactly what is very surprising. And its ability, I mean, the interesting thing is the ability of ChatGPT to understand your request, right? And I don't know, for those of you, if you remember, before ChatGPT, we got GPT-3, right? But there was a problem with GPT-3, and I will dive more into it in the following slides. So when GPT-3 came, it was already a kind of small revolution, but it was not at the scale of what we've seen with ChatGPT. Why? The fact is that if you have ever played with GPT-3 before, you will understand that it's more like an auto-completion system, right? Of course, it can kind of, sometimes it mimics a little bit some form of understanding, but most of the time when you like, if you prompt, you can prompt him with a text, and it will just try to predict the following tokens or words, if you want. And that's exactly what it was trained for. It was just trained to kind of autocomplete anything you give him, you give it. And that's exactly also I mean, where the challenge from GPT-3 came from. It can just fabricate anything for you. Like you can try that and put anything, and it will just continue whatever you have started, right? And even if you ask the system, please help me with this, it will not understand it. Like if you just imagine you have you give GPT-3 like a multiple choice question, for I mean, for instance, it may just continue with some other questions. Do you see what I mean? So even if you may even write the question at the beginning, and then you may give some options. It may just continue with giving you more options or asking other questions. Why? It doesn't understand that what you want is not just it's not just a continuation of what you wrote, but actually you want it to reason or to answer your request. And that's where I mean, what we call the misalignment problem is coming from, because then you want the system to do something, but it is not doing it, right? And it does not understand what you want it to do. And it is not, it's false because it was not trained to follow instructions. And that's what the paper sharing with you guys today from OpenAI is exactly doing, is training a model called Instruct GPT. And that model would be specialized at following instructions. And what they realized in this paper is that uh, human could even prefer a way 100x smaller model compared to GPT-3 if that model is capable of following their instructions. This is, it looks intuitive, right? Like, just imagine, would you like to have, I don't know, the brightest dogs? I don't know if you guys like dogs, but just imagine you have a very intelligent dog, right? And on the side, you have a pretty dumb dog. But the dumber dog knows what you mean. Do you see what I mean? Like, can follow your instruction, even if it is not as smart as the other. But the other is like, no, 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 I don't understand your request. Even if it is capable, that dog is capable of doing what you want. If it cannot answer your request, you may end up preferring the dumber dog, right? So that's exactly what's happening here. So we have a smaller model that's preferred over a huge model, but I will give more details because in the paper they experimented with not only that small model, but an intermediate model that's 6 billion parameters, and um, also a bigger model that's of the size of GPT-3. So I was talking about alignment. How do we make the model align, and what does it mean to align the model first? Um, I think we need to understand why do we need robots, and what should they do? What should be their purpose, right? What should be their objective? And I think I've derived this from the paper, and I think it summarizes a lot of things. First, we want a robot to be helpful, right? Like, if you use ChatGPT, you want it to be able to answer your request. That's a good thing, right? But second, you want the robot to be honest. So sometimes I'm sure you guys have experimented that, right? Like, sometimes language models will just invent things. That's what we call hallucination, right? Like, you you ask it, oh, please, um like, give me a few books about, I don't know, a few fiction books, and suddenly you may have books, like it may just suggest you books that if you go on the internet and you search for it, you won't find it because it has just been invented. Don't look too much sometime. I think with time we're getting less and less of this problem as people have been tackling this problem of hallucination. There is a last point. So we want the robot to be harmless. What does it mean? So we don't want the robot to output toxic um, language, right? Or we don't want the robot to give answers to, let's say, illegal requests, right? If someone is asking for, how can I don't know, create a bomb, I think we all know that this is illegal, right? So we want the robot to stay in the boundaries of what law or human values agrees upon, right? So that's exactly something that we want the robot to understand also. So those 3 points are very important, and I think we need to keep them in mind as we are going through this paper. And how do we achieve that? Right? It's easy to say, okay, I want GPT-3 to understand my request. I want GPT-3 to hallucinate less. I want GPT-3 to be less toxic, things like that. But how do I do it? That's exactly where reinforcement learning from human feedback is, a very powerful tool. And I will explain why. So let me give just a brief overview of the three big steps that OpenAI was taking in this paper to achieve this goal. So the first step is collecting supervised data. So just imagine you already have GPT-3, right? Like you already have a model that's pre-trained on the whole internet, right? And the goal, let's keep it in mind, is to make that model understand your request, right? So if you ask a question, you want the model to answer that question. So what is the easy way to start with? You can just create a data set. So a data set where you have a bunch of questions and a bunch of answers, right? So and that data set can be varied. It can be like diverse on different subjects and so on, right? And so you have questions and answers. So the questions are what we call prompt here. And so you want the system to learn how to answer how to reply those prompts. You can simply fine-tune the GPT-3 model using that data set that you've built, right? You take GPT-3 and you just find what I call fine-tuning is that you just you continue training the model, but now instead of just like learning from the internet, any text, your model will be now learning from questions and answers. So it will just learn how to answer those questions. And that's what we call supervised fine-tuning. Okay, so we take GPT-3 that's already pre-trained on the whole internet, and we fine-tune it on a question answer, or let's say prompt answer database. And that's the first step. And if you do it and you test your model, you will see that, okay, your model is already kind of capable of understanding like your requests, right? And that's cool. That's cool. Now, the challenge might be something. So the model might be good at answering questions, but it doesn't mean that the model is good as giving you answers the way you want it to give you. Do you see what I mean? It's like someone is very, and let's say someone understands your request, but might still reply in way that in a way that is not very convenient to you. Has it happened to you before? You know that the guy understands your request, but the answer he or she is given is simply not the way you want it to be. So how do we tackle that? That's where step 2 is very important. So step 2 is what we call the reward modeling parts. So you will simply train a model that will, the goal of that model is to rank answers. So just imagine for the exact request or exact prompt, you have 2 answers, and you want to create a model that would be able to tell you this is the preferred answer. You see what I mean? And that's what the reward modeling is for. So you just collect many prompts, and you have maybe, let's say, 2 answers for the same prompt, and you know which one is preferred by humans, for instance. Okay. And now you train a model that would just output a reward for, like, it will take a prompt and an answer and will output a reward. And what you want is that so for let's say for prompt 0, you have the prompt might be please give me a recipe of I don't know, chapati. Okay, let's say you want to cook chapati, you don't know how to cook it, and you want a recipe, right? So to that prompt, you can have different answers. So let's imagine that you have two potential answers, and there is one answer that you would prefer. So we would give to the system first your prompt plus the first answer, okay, and it will output a reward, and we will give again another the same prompt but with another answer, and the system will output the reward. So you have for the same prompt, you have two rewards according to the answers, and you want the reward model to give a higher score to the answer you prefer, right? Because by default it doesn't know your preference, right? But you want it to learn that you prefer this answer over over the other answer, and that's exactly what the reward modeling is for. So let me give again a summary. First step, we train the model to understand how to answer questions, but it may not understand exactly which type of answer we would like, or how the answer should look like for us, or let's say some preference for us. Like you can have preference in terms of the way you want to cook that stuff. Okay. And so the second step is important for that and will help for a single prompt, and different answers will generate several rewards, and will try to predict, give a higher reward to the answers that you would prefer. After that second step, there is a third step, and that third step is the reinforcement learning stage. So let's say you already have your model, right? Your reward model that knows from a single prompt and several answers what would be your preferred answer. Now you want to update the model that you have pre-trained in step one, like the model that you have fine-tuned. Sorry, the model that you have fine-tuned in step one. You want it now to be align with the reward model that you train in step two. So keep in mind, step one is a fine-tuned version of GPT-3, okay? Step two is a reward model that's not GPT-3. Keep that in mind, right? It's just a reward model. You can think of it as a kind of like ranking model, okay? And now you want to align the model, the fine-tuned GPT-3 that you got out of step one. You want to align it with a reward model that you've trained during step two. And that's what step three is for, okay? And that's where we use reinforcement learning. Here we would, OpenAI was using a technique called PPO for proximal policy optimization. And it's a way to take the supervised fine-tune model and to change the weights, like let's say to update the supervised fine-tune model in such a way that it will improve the likelihood of higher reward answers. I hope my explanation is clear enough. But we will come back to more details. Again, if you have questions, please feel free to ask them in the chat, or raise your hand if you want. Any questions so far?
I think so far there aren't any questions, but we're just keen to hear what's coming next.
Okay. Okay, cool. So, okay, here is just a graph summarizing, I would say, the main output of this paper. And so what they call win rate is the proportion of time when a model is preferred over the basic supervised fine-tuned model. So the supervised fine-tuned model, remember, is the model that has been fine-tuned on questions and answers, right? But it doesn't know preferences. Do you get it? The fine-tuned model does know how to answer questions, but doesn't know preferences. And so how does it compare to models where we can actually tailor the model? We can tailor the model to our preferences. So GPT here is for GPT-3. So no fine tuning here. This is the basic GPT-3, and you have it in different sizes, right? The 1.3 billion parameters, 6 billion parameters, and 175 billion parameters. And you can see that when you go from basic GPT to prompted GPT, which is kind of like you give it instructions, it's already better, right, at following the instructions, which is expected, right, somehow expected. When you do fine-tuning, just fine-tuning of GPT-3 on questions and answers, you also have a gain compared to just prompting GPT-3, which means that prompting is good to improve relevance to human preference, but it is not enough. So fine-tuning the model on questions and answers gives a pretty big jump, right, in human preference. Now, from there, when we use, let's say, the reward model plus reinforcement learning stage, you can say like PPO, let's say PPO and PPO PTX. I won't dive into the difference right now, but both are similar. Let's say both are actually what is representing Instruct GPT here. So both have a higher win rate compared to even the supervised fine-tuned model, which means that the reward modeling plus reinforcement learning from human feedback part is very important in aligning the model to human preference. So that's the main thing we need to keep in mind, and that's the main message of this paper. And what you can even see is that the smallest model, when it is let's say PPO, like when it is fine-tuned for human preference, has already like a huge jump in win rate compared to even the highest I mean the biggest model. So if you take the biggest model, GPT-3 model, without any like prompting on or fine-tuning, the preference rate is just about above 20%, right? But if you take even the smallest model on PPO or PPO PTX, which is with preference fine-tuned versions of the smaller version of GPT-3, you already have a higher preference for human. I mean, let's say a higher win rate for human when it comes to human preference, which means that the size of the model, of course, can be correlated to human preference, but if you don't fine tune it and if you don't do any kind of reward and reinforcement learning, then you will see a gain even from the smallest model, which is already huge. Other results from the paper, and I think this is just a continuation, like this is just diving more into what I've shown in the previous slide. Instruct GPT obeys better, which means that it it can follow instructions. It has less hallucination, and let's say it is simply more appropriate. It has a language that's more appropriate, at least that's what is rated from humans who were, the laborers who were recruited to evaluate the performance, at least the preference in terms of language, in terms of hallucination, in terms of following instructions and so on. So if you have a dog and you you want it to obey you, you all know that, right? You need to train it, right? To know what are your requests, or how do you want the dog to behave when you say this or this. And this is exactly what's happening with the model here. We've aligned it with human preference, and then it's better at following what we want. It's also more truthful. So as I said, we want the model to be truthful. First, helpful, honest. Honest means truthful, right? So this is a truthful benchmark, truthful QA benchmark. And so what you see in gray is the truthfulness of the model, okay? So there is already a jump when you do supervised fine-tuning, SFT. But there is also a jump when we go to PPO, the PPO stage. And please bear with me, I haven't explained yet the difference between PPO and PPO PTX, but I'm coming to that. And Instruct GPT is also less toxic. And I think that's kind of also expected. Okay, so let me explain something, because the story looks very nice so far, right? Like, oh, we are capable of taking a model and aligning it like to whatever we want, right? But the question is there a cost to alignment? Is there a cost to, like, just imagine if you are just trained to follow instructions, you might become maybe less creative, right? You might become even less performant at doing tasks that requires a certain level of freedom, right? And that's exactly what is called the alignment tax. So alignment tax is simply a gap between the, let's say, preference fine-tuned version of a model compared to the model that has not been fine-tuned for preference. So it is known in the literature that if you make the model align to your request, it becomes somehow dumber. It becomes less capable of achieving some tasks. And that's what you're seeing on this graph, for instance. So translating from French to English, here we are reporting the blue score, which is a metric very used in machine translation. So higher the better, okay? Higher the better. And what you can see is that the GPT-3 model, which is in the blue line, has the highest translation performance, right? And so when you go to just supervised fine-tuning, it decreases a little bit. And we know that supervised fine-tuning is already a little bit better at following let's say, request, right? So that ability of following request is coming with a lower performance in the translation task. And when you go from supervised fine-tuning to let's say simply PPO. So PPO is let's say, call it the basic basic way to align the SFT with preference. So we use we take the SFT and then we try to make it more aligned with a reward model that we've trained. Okay, and look at the gap in performance with GPT-3. It's really huge, and that's what so we call it here PPO tax. Okay, and the question is, if the tax is so high, who is going to use the aligned model? Because just imagine that for the sake of having a model follow your instructions, then you destroy its ability to translate. Are you going to use that? I'm not sure. So we need to find a trade-off, and that trade-off is exactly the PPO PTX tax. Okay, and what is the difference between the two approach? So the PPO tax, the PPO framework just try to align the model with the reward system that you give it, right? So it doesn't account for is what I'm outputting kind of accurate, very accurate or not. It will just output things that try to be kind of to follow the instruction, but in following the instruction, it might miss the final answer. And so the PPO PTX try to solve that problem, or at least mitigate that problem, by integrating in the loss function of the reinforcement learning, or let's say in the reinforcement learning objective, we now integrate the likelihood of the pre-training distribution. So remember that the pre-training distribution, which is kind of GPT, like more similar to the original model GPT, would be more performant, right? So now you instead of just training the model to get let's say to give you answers that maximize your preference, you want to maximize your preference subject to the fact that the answer is likely. And so I think, okay, this is maybe an example of the difference between what GPT-3 will give you versus Instruct GPT. I feel like maybe I will come back to this slide because I want to continue on what I was saying regarding the PPO and or PTX before maybe coming back. This is just an example to show you, okay, like the difference between auto-completion from GPT-3 and generating answers that follow your instruction. So I was talking about, I think I've been talking about reward model from the beginning, but how is it trained? Because that's a good question, right? How is any machine learning model comes with like a loss function, and the loss function is something we want to optimize for. Okay, so here we want to minimize the let's say loss function here, and what does it like? What are we taking into action when we are minimizing this loss function? What are we doing? Because the loss function is not random; it's there to like constrain the model to go into a given direction. So R5 here is what is the reward model. So if you give the model a prompt X and let's say on an answer that's Y, maybe YW for let's say a preferred answer, R5 will give you a scalar value, like what is the reward given to that particular answer, condition, of course, on your prompt. Okay, and you can also have another reward. You can also compute another reward from an answer that you may not prefer. So you still have the same prompt X, and you have another answer YL that you may not prefer. And so you want the model to you want the reward model to learn to predict the reward such that the one predicted for your preferred answer is higher than the one predicted for your less preferred answer. I hope you get what I'm saying. So just imagine that you so R5 with X and YW is, I don't know, like let's say 0.7. Okay, you want R5 with X and YL to be 0.5 because you know that you prefer YL over YW. Remember again, YW is your preferred answer and YL is your less preferred answer. So you want the reward for YW to be higher than the reward for YL. And that's exactly what the reward system will learn. So we know how to learn the reward model using this loss function. The last step now is using the reward function that we've learned in the reinforcement learning stage, where we want now to align remember, the supervised fine-tuned model, we want it to align with a reward model such that the answer given by, let's say, the new version of that supervised fine-tuned model will give higher reward to those answers. Do you see what I mean? So when you have the SFT models, which the supervised fine-tuned model, it doesn't know yet how to maximize the reward, right? But you already learned a system that knows how to rank the answers from the SFT model. Now you want to update that SFT model such that the answers it will give you will have higher reward. And that's what is done here. So the first part of the equation here is simulating that, okay? And the second part is simulating something. Okay, the first part is maximizing or is aligning your SFT model to your reward model, right? But it may lose its ability to predict or to accurately achieve your task, such as translating, for instance, right? So the PTX part, and you can think of it as, let's say, making the pre-training, let's say, making the output more likely to the pre-trained data sets, or let's say distribution, okay? So the second part of the equation is just making that output, let's say, more likely to be accurate, and that mitigates the problem, let's say the alignment tax problem. So for PPO, without that, let's say, mitigation step, you can just zero the gamma stuff here. So you can zero the second term here, and you just have PPO. So if you want to get PPO PTX, then you give a non-zero value to gamma, okay? And then you will see the gain I was showing here. So the gain from PPO, you can see that we can reduce the alignment tax from PPO to PPO PTX just by applying applying that additional term, which is, you can think of it as a penalization term that will, or a regularization term that will find a trade-off between aligning the model to your preference versus keeping the accuracy of the answer. Okay, now you may ask me, we're talking about alignment, but who is the model actually aligning to? That's a question that's interesting because alignment is not like we don't have a gold rules for alignment, right? Alignment depends on many things, and so the way the final model will behave depends on first the pre-trained model. Like, of course, GPT-3 has been trained on the whole internet, right? So you could expect, for instance, GPT-3 to be, let's say, biased toward high resource languages like English, right? Because most of the internet is in English, right? The behavior of the model also depends on the fine-tuning data you're using. So remember the supervised fine-tuning stage, where you take GPT-3 and then you fine-tune it on questions and answers, okay? If your questions and answers are, for instance, specific to, let's say, a particular domain like health, so you have to expect your final model to be to understand more health-related requests compared to, I don't know, more day-to-day requests. Okay. And the last point, which is, I think for me, one of the most important points, if not something that is maybe where we really need to be careful, is the alignment method. When I say method, of course, it includes which type of reinforcement learning algorithms is used. That's true. Like here we're using PPO. There are other types of alignment methods. But even when we're using, whatever alignment technique we're using, we will have labelers who have their own preference, right? Of course, here, for instance, OpenAI is giving the labelers some instructions, right? Especially coming from the researchers. So they mentioned in the paper, for instance, that they would have they had a chat, like a chat channel where they discuss. So there are many edge cases where the labelers don't know what to answer, and they will come and ask the researchers, please help us. What should we answer here? So first, we already have a bias to labelers' preference. So even the selection of the labelers can have an influence on the final behavior of the model, right? And secondly, the researchers or the labs aligning those models will also have a huge influence on how they behave. And I think that's something that should be that we should always be aware of, that those models don't perform independently of human, I would say, human preferences. Especially, we want the model to understand us, but then the model might be also more biased toward certain types of ideologies or let's say way of thinking and so on, right? That might, let's say in different cases, according to the cases, might be good or bad. Okay, I will stop there. And I think the main key takeaway, the takeaways I would say here are mostly that making a model bigger is not enough for us human, because we don't just want like a more capable model. We want a model that can understand us better. So even if the capability of a model increases with the size of a model, it does not mean that we are going to prefer the more capable model. We do prefer the model that can understand our requests. And that's where reinforcement learning from human feedback is very important. We've shown, or at least OpenAI here has shown that human have a clear preference, right, of the instruct GPT output, and you can see that in all the metrics, right? And there have been also many other studies even based on open source language models such as the llama models, for instance, that show that aligning the raw model with human preference is almost always better or preferred by humans. And they have also shown that they could reduce hallucination. So the model is kind of more truthful. They can also reduce toxicity. And of course, we all know the challenge of the alignment tax, that making the model align sometimes, most of the time, makes it dumber. But here they have suggested an approach to mitigate that problem with the PPO-PTX approach. And so, yeah, that's it. I will stop here. And I hope that it was not too technical. I do hope so. And that you have understood most, at least, of my presentation. Thank you very much. And yes, I'm open to your questions.
Awesome stuff. As I wait for anyone to populate questions on the chat, first of all, Gilles, I just want to say thank you. It was really informative. I came here knowing much less than I thought, so I'm very excited. I did have a few questions, but you've already answered them even before I asked them, so I'm very grateful. I will ask them just for the sake of clarity. One of the questions I have is, does it mean that the newer models, or rather the reinforcement training models, can only be used for scenarios that it have been trained for? Or does it use the policies generated to reapply to existing information set? I think you've already answered that in that it may become dumber overall, but better suited for what it's been trained for.
Yeah.
Also, I had a question on how do we contextualize, you've mentioned harmlessness, like how do we contextualize matters concerning like ethics and morality, because what is harmful is mostly the same, but varies from context to context, from people to race to gender to different things. But you said also the labelers that we choose drive a lot of the sanity of the data. So that one has been answered already for me. Thank you for that. The only question I would have, but it's more general, not just for you, Gilles, everyone who's been attending, is what would be some of the best potential use cases for Instruct GPT over GPT-3, or rather, these reinforcement learning reward models? What's, just in simple terms, what would be an example use case that you think would be best suited for this?
Yes, thanks very much. So maybe something that I forgot to mention is that ChatGPT is a direct outcome of the Instruct GPT paper. So you can consider ChatGPT to be actually Instruct GPT, but on maybe so if you remember when so ChatGPT came, so it was GPT-3 that took exactly the same like steps here. So the supervised fine-tuning, the reward modeling, and then the reinforcement learning stage, right? So all the applications you are seeing that are derived from ChatGPT and other language models right now, most of them actually fit with what the Instruct GPT could be applied for, right? So just imagine a case, and that I've been involved with an NGO called Jacaranda Health, and so they have created an application for models called prompts, especially vulnerable models in rural areas in Kenya. And so those, not just models, but also incoming models, so pregnant women who have questions. They have questions about, the pregnancy, the baby, and so on and so on. And so they could ask those questions through the system. And so to kind of help, so they have help desk who kind of review those questions and so on. But they have thousands of questions per day. So a way for them to augment the capability or to make the help desk more productive and to be able to handle thousands of requests per day is to use generative AI. So what they have, they had a huge data set, internal data set of questions and answers, questions from the models and answers from the help desk. And with that data set, they fine-tuned Llama 2 and even 3. They have produced a version for Llama 3. So they have fine-tuned that Llama 3 version on the huge question answers database, okay? And that is the instruction fine-tune stuff. And they have already seen a big jump in the ability of the model to understand the requests. So, and there is also something called something called domain adaptation, which is, I mean, to be more precise, it's called continual pre-training. So take the example of GPT-3. So it has been trained on the whole internet, right? But imagine you have let's say a case in healthcare, right? And you wanted to understand more of healthcare concepts, especially let's say in Kenya, where for the application I was talking about, terms both in English and Swahili, or sometimes code mixed sentences where people mix English and Swahili. How do you make it? So sometimes people will take the basic model, which is, for instance, Llama 3. You can say Llama 3 is an equivalent version of GPT-3, okay, which is just trained on the whole internet. And then you take your Llama 3 and you can continue the next token prediction on a huge databases of, let's say, of healthcare, I would say, sentences. Okay, and then your model will be better at understanding healthcare requests first, and then that model that you have continued pre-training, you can use it for the SFT, the supervised fine-tuning stage, where you fine-tune it on your questions and answers. And you already have a huge gain. And that's, for instance, what Jacaranda Health is doing. And there are other applications in many domains. You can apply it actually in any domain. And you should have similar gains.
Okay, actually, that's a really comprehensive answer. Thank you. So I know we are out of time and I don't see the other questions, but I do want to thank you, Gilles, and everyone else who's attending. It was a very good session. We're looking forward to the next one. And I think, yeah, that's a wrap for this year. If there's any other questions, of course, Gilles has left his contact details there. If you want to get to the nitty-gritties of it, please feel free to contact him. And for Gilles himself, we'd like to say, so we appreciate your time and you're always welcome to come back again.
Thank you very much for inviting me. It has been a pleasure, and yeah, looking forward to another presentation around.
Awesome. That's a wrap for that. Guys, enjoy your Christmas.
Thank you, you too.